All right, so this is a video to explain the first lesson for conic sections, which is ellipses. Conic sections are equations that can be modeled as thinking of two cones extending infinitely in the upward and downward direction, and slicing across that cone in a certain way. So we've dealt with circles, which would be like cutting straight across the cone, and you get a nice symmetric shape. But if you imagine tilting and cutting down across the cone, you would get sort of a stretched out circle. So today we're going to focus on these. We're also going to learn about hyperbolas, which are when you cut down across the cones and you get these curves that are sort of pointing away from each other. So an ellipse is going to look like a circle that's been elongated. And then there's also parabolas, which you've learned some things about from Algebra 2, so we're not going to go into those in geometry. So today we'll talk about how to graph an ellipse, both from standard and general form, and we'll talk about the different parts of the ellipse and how you would identify those, and how to complete the square to get it from one form into another, which is going to be kind of like we did for circles. Why would we care about ellipses? A few different reasons. Most of them would come up in like a physics context. A big one is that all planets orbit in an ellipse. Kepler's laws, if you ever take an astronomy class, you'll talk about this. It turns out that planets orbit in ellipses. Also, things like elliptical mirrors, or parabolic mirrors are reasons that conic sections would be important. So again, if you continue with physics, you would see these things. The definition of an ellipse. So the definition of a circle, right, is all the points that are the same distance from a center, right? We call that distance the radius. An ellipse is a little bit different. So what we do is we pick 2 points. Okay, so F and G in this picture. And we call those the foci, which is the plural for focus. And the idea is you take any point on the ellipse and you measure the distances back to the foci. Adding up those distances will always be the same. So no matter where I go, if I take this distance and this distance, it will always add to the same number. And when you do that, depending on where you place the foci, you end up getting a circle that is stretched in one direction or the other. The parts of an ellipse, so circles are easy because we have the center and radius, but there's a lot more going on for an ellipse. First of all, we have the center, okay, just like for a circle, but we also now have the foci. We also have the vertices, okay, so the ends of the ellipse on the longer axis are called the vertices. Sometimes we call these the covertices, covertex and covertex. I forget if there's a hyphen or I don't think there's a hyphen, sorry, just covertex. And then we talk about, where a circle has, again, a single radius, right? It's the same all the way around. An ellipse kind of has two radii. We have a radius in the x direction and a radius in the y direction. And depending on which one is longer, the longer one we call the major axis, and the smaller one we call the minor axis. So in this case, it goes horizontally, but it could be, you could have an ellipse like this, where the major axis goes up and down, okay, instead of left and right. And so when you are graphing, you're going to need to find all these features. One other thing that's going to be helpful for us to know is something called the focal radius, which is what it sounds like. Okay, it's the distance from the center to the focus, and it's symmetric on both sides. The equation for an ellipse. Okay, we remember the equation. Again, I keep relating things back to circles because it helps us remember some similar parts. Okay, so we knew that this was for a circle. An ellipse is very similar. We still see this x minus h, okay, y minus k, and that's going to work the same. The center is still going to be h comma k, just like before. Okay, now we have a new part though. We're dividing by r sub x squared, which is going to be the radius in the horizontal direction. And it will be easier to just show you this with a picture in a moment. ry squared is going to be the radius in the y direction. And then it's always just going to be equal to 1, the way that we're setting these up in general form. And later on, we'll talk about finding the focal radius. We're going to say that the focal radius squared is equal to the major radius squared minus the minor radius squared. Not going to prove that formula, but I'll just say it comes from setting up Pythagorean theorem in a certain way. We'll see that in a moment. So the first thing we might ask you to do is to graph something like this, okay, that's already in general form. And so the first thing you would do is you list your center. And just like for circles, you do the opposite. Okay, so we'll go ahead and put that on the graph, 1 comma negative 2, put a dot. And then we'll take our 16, and so what that corresponds with, right, is rx squared. So rx is going to be 4, and ry is going to be 3, right? Take the square root. And then, so what that means is what we're going to do in the x direction is we're going to count out 4 units. So 1, 2, 3, 4. Put a dot. Okay, and then we'll do the same thing in the other direction. 1, 2, 3, 4. Put a dot. And now we count up. 1, 2, 3. Okay, in the y direction, and then 3 down. So we get a radius of 4 in this direction and 3 in the y direction. And now connect, and just do your best to make this like an oval shape. It doesn't have to be perfect. That is the general shape of the ellipse. We would ask you to go a little bit farther and to find the foci, okay, the points where those are located. And that's where you need to know this focal radius. Okay, so what we usually say is f squared equals big R minus little r squared. Big R being the major radius, so the bigger number, and little r being the smaller number. Okay, so going to this example, we would do f squared equals, and then take these numbers, okay, 4 squared minus 3 squared, or you could just go back to these original numbers, by the way, 16 and 9. Either way, you end up getting f squared equals 16 minus 9 is 7, and so f equals root 7. So what that means is we're going to go a distance of root 7 away from the center. Okay, remember back to this picture, the focal radius was the distance from the center to the focus. So what we just found is that that is the square root of 7. But that means we're going to need to go root 7 in both directions. Okay, so if we come to our picture, the foci always go in the direction of the longer axis. So in this case, our foci are going to go this way. Okay, again, if it was an ellipse shaped like this, then our foci would go up and down. They always go in the longer direction. So if we think about it, right, if our foci go this way, the y coordinate is not going to change. Right, it's going to stay along that same y value. So we know one of the coordinates of the points before we even begin. We know it's just going to stay negative 2. Oh, I should make these bigger. Hold on. Okay, let me make this one a little bit bigger. Sorry. All right, what we don't know is the x coordinate, but what we're going to do is we're going to take the x coordinate of the center and we're going to go root 7 in both directions. So we're going to do 1 plus root 7 and 1 minus root 7. And so you're taking the x coordinate and you're going over by the same amount. Now, to draw that on the picture, we wouldn't ask you to do that, but what you would do is you just approximate. Okay, root 7, I'll just get that real quick, is about 2.6 approximately. Okay, so if you were going to draw the foci on the graph, you would go like 2 units and a little more, and 2 units and a little more. But we're not going to ask you to draw those on the graph, so this would be good enough. Okay, so this would be all the information you would need to give. First of all, you would draw a picture, just like I've drawn it here, would be good enough. You would give the center, you would give the 2 radii, x and y, and then you would also find your foci, and that would get full credit. Of course, this one's already in general form. Life will not always be so simple. Say on the SAT, they will often give it to you like this. And so what you will need to do is you will need to convert this into this form, and that will allow us to graph it. Okay, the way we're going to do this is very, very, very similar to what we did for circles. Okay, we will begin by moving the terms around and putting x's by x's, y's by y's, and then subtracting, right, doing the opposite to get the number to the other side to get it out of the way. Okay, what we have to do at this point is we need to get x squared alone. And so what we do is we look at these two terms and we pull out a common factor. Okay, 25 goes into 200, so we can pull out a 25. Okay, it goes in 8 times. Now leave a space because now we're going to complete the square. All right, same thing here. Pull out a common factor, pull out the 9 in front of the y squared because 9 goes into 18 twice. Now you're going to complete the square. Let me use a different color for this. We'll use blue. Pretend like the 25 is not there for a minute. Right? How would you complete the square if it was just this? Right? You would take -8 divided by 2 is -4, squared is +16. So put plus 16. Okay, same thing here. Just ignore the 9 for a minute. You would divide 2 divided by 2 is 1. 1 squared is still 1. Now, what a lot of students will do is they'll do plus 16 plus 1. And that's wrong. Because think about what you actually did to the left side. All right, now let's bring these numbers back. You didn't really add 16 over here. You really added 25 times 16. Right, you're going to need to distribute the 25 back in. So 25 times 16 is 400. 9 times 1 obviously is 9. So to the right side of the equation, you need to add 409. Okay, so again, because of the distributive property, you didn't really add 16, you really added 400. And that's just the one little tricky thing with doing these. All right, now we clean all that up. So leave the 25 in front. Factor this like you did for circles, x minus 4 squared, okay, just like before. Leave the 9 in front. That will be y plus 1 squared. And then when you add all this up, you get 225. You're going to get some big numbers for this. Feel free to use a calculator. And we're almost done. If you look back to the general form, you'll remember I said it always needs to equal 1 for this to work out nicely like this. So the last thing we're going to do is whatever number we get over here, we're going to divide by that number, because anything divided by itself is 1. But of course, if we divide one part of the equation, we must divide all parts. But something nice will happen now. So first of all, this will become 1. But there's always going to be this nice switching around that happens. So take your calculator, do 225 divided by 25, and you'll notice it goes in 9 times. And then do 225 divided by 9, and it goes in 25 times. Right? That's not a coincidence. That will happen every time. The numbers will switch places. And so you will end up with, let me give myself some room, x minus 4 squared over 9 plus y plus 1 squared over 25 equals 1. Now we are done converting it into general form. You still need to graph it. And when we ask you to do this on a quiz or a test, we would ask you to graph the picture and find all the information. So let's do that. First of all, the center is 4, -1. So let's go ahead and graph that. 4, -1 is down here. Let's go ahead and get our Rx, okay, which is 3, and our Ry, which is 5. Okay, so whatever's underneath the x is what's your Rx, whatever's underneath the y is what's your Ry. Just take the square root. And now we graph that. Okay, so we're going to go 3 in the x direction, counting over 3, and then 5 in the y direction. So it's going to be longer in the y-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and so when I draw this, you can see it's stretched vertically. Last thing to do would be to find your focal radius. Again, f squared equals big radius minus small radius squared. So f squared is going to equal, in this case, 5 squared minus 3 squared. But this works out really nice. This is a Pythagorean triple, 3, 4, 5 right triangle, so you end up getting f is just 4. So now to find our foci, okay, it's always going to be 2 of them. And you're always going to know one of the coordinates because you're either moving left and right or up and down. In this case, we're moving up and down. And in this case, it worked out to a nice number, right? The focal radius is 4, so it's easy enough to just find it on the graph. Go up 1, 2, 3, 4, put a dot, right? That's one of your foci. Down 1, 2, 3, 4, put a dot. That's one of your foci. And you could just look at the graph and see, all right, the x-coordinate did not change. So it's always going to be 4. The only thing that changed is the y-coordinate. And so you went up to 3 and down to negative 5. Okay, that's going to get you full credit. Having all of this information is what you need, in addition to the graph. Again, we wouldn't ask you to draw the foci because usually they're going to be like a square root, and that's just annoying to have to draw them. So we just want you to know where they're located. If you can do this example, you understand everything there is to graphing an ellipse. So why don't you try this yourself? Okay, if you're watching the video, why don't you hit pause, try this one yourself, and then I will catch up with you when you unpause. Okay, so rearranging. I'll go faster now. Okay, you can do this all in one step. You can even, some of you may just like skip right ahead to pulling out the number, and that's fine. Just again, leave yourself some room so you can complete the square. Completing the square, again, I'll use a different color. This is going to be plus 4. This is going to be plus 25. But again, you really added 16, and you really added 225. And so that's all going to come out to 36 when you're done. Okay, so writing that out. Go ahead and factor x minus 2 squared plus y plus 5 squared equals 36. And then remember the last step is divide everything by 36. And then the 4 and the 9 are going to switch. Okay, 4 goes into 36 9 times. 9 goes into 36 4 times. So that's going to work out. You would write all your information. The center is 2 comma negative 5. Your Rx is 3. Your Ry is 2. Your focal radius is going to be 9 minus 4. You end up getting the square root of 5. So at this point, you may want to draw a picture to just kind of help you visualize. So 2, negative 5 is down here. 1, 2, 3, 4, 5. Go 3 in this direction, 3 in this direction, 2 in this direction, 2 in this direction. So the longer axis is the x direction, which means our foci are going to move along this axis. So we know the y coordinate's not going to change. Right, so you get one coordinate for free. So the center is at negative 5, so are the foci, because we're moving left and right. And then you just take your x coordinate and then just add your focal radius and subtract your focal radius. And you just leave it like that because you're trying to get exact answers anyway, so you could get a decimal on your calculator. There's no need to do that. This would get you full credit. If you had all these pieces, nice job. If you didn't, again, pause the video, try to figure out where you went wrong. It's probably an arithmetic error of some kind. But this is everything you need to know for graphing an ellipse. Okay, so this is just summarizing the process. You want to rearrange the x's and y's like you did when you were doing circles. you need to pull out whatever's in front of the x squared or y squared, otherwise completing the squares doesn't work as nicely. You complete the square inside the parentheses, but you need to remember you've really distributed and you really got 4 times 4, right? You didn't add 4, you added 16. Same thing, you didn't really add 25, you added 9 times 25. And then the last thing you do is always divide so that you end up equaling 1. And that gets it into the form where the numbers on the bottom are the radii. All right, so the last sort of question we would ask you is something like this, where we give you some information and you need to work backwards. So you are trying to fill in the pieces for an equation like this. All right, so let's see. Find an equation of an ellipse that has foci -3, 2, and 5, 2. So you may want to draw a picture for this, by the way. Let's see, -3 and 5 and 2. Okay. The first thing we need to realize is that the foci are always equidistant from the center. And another way of saying that is that the center must be in between them. It must be halfway between them. So halfway between -3 and 5, you could just think about it, or you can just add them up and divide by 2, right? Because really what you're doing is finding a midpoint. And so 1, 2 would be in the center. Well, that's half the battle, because now you already know the top of the fraction. Okay, so you can start to fill in your equation here. X minus 1 over something plus y minus 2 over something. You've got partial credit. Major axis of length 10. Okay, the major axis is the longer one. Well, we said that's always going to go in the direction of the foci. So your major axis is this way, and that has a length of 10. But that means, right, think about your ellipse here for a moment. That means the radius in the x direction is going to be 5. So now you know Rx is 5. But you want to put Rx squared in the bottom. So you're going to put 25. So now you're just missing Ry. So this is where the focal radius comes back in. F squared equals big radius minus small radius, major minus minor. Well, here's the thing. You know the focal radius. Okay, before you were finding the focal radius, but this time you know what it is because you know where the center is located, and you know where the foci are located, and you know that's a distance of 4. So you know this is going to be 4 squared equals, you know the major radius is 5. You're solving for the smaller radius. Okay, of course, though, this works out nicely. You would go ahead and solve this equation. You would end up getting -9 equals -r squared, and so it is easy to see that r will equal 3. That means, right, if ry is 3, we want to put 9 in the bottom of our equation, and we're done. These can be tricky. The key is to fill in the information you know, and then usually drawing a picture can get you some information, and also using this can get you the rest. And that's it. So at this point, if you go to Canvas, you will see there's a new module, okay, Unit 5, Part 2, and there's a lesson and an assignment for ellipses. 2 of them are asking you to draw the ellipse, completing the square and all of that. 2 of them are asking you to work backwards, given some information, find the equation. Please email me anytime if you have questions, and I hope you have a great day. Thanks.